Alright, so I'm hoping that you have found the first two videos on covalent compounds, and you've also found the video on ionic compounds, writing the names from the formulas. This one is going to be about the ionic compounds, writing the formulas, and remember this process works for all three types of ionic compounds: binary, ternary, and those that contain transition metals. I am going to do a separate video on just the transition metals, so right now we're only going to focus on the binary and the ternary kind. But remember, all formulas for ionic compounds are written according to the charge on their ions. How do you know the charge on the ion? You can either use your periodic table and understand how the ions change as you go from left to right across the period on the periodic table. Or if it's a polyatomic ion, it's a memorization of the charges. But remember, metals typically form cations. Non-metals or polyatomics typically are your anions. The only exception to the polyatomic being a cation is ammonium, NH4 plus 1. As you're doing these, writing the formulas, just keep in mind that all of the charges in an ionic compound must total 0. So you can work at the mental math way, where you would have to say, okay, if I have a plus 1, I would need 1 minus 1 to cancel it out. Or if I had a plus 2, I would need 2 of a negative 1 ion. But the easiest method is this crisscross method that we've been practicing in class. And in a nutshell, remember, the charge on the cation then becomes the subscript on the opposite element, which would be your anion. And the charge on the anion becomes your subscript on your cation. And then you just have to watch out and make sure that everything has been reduced to lowest terms. So I've got a couple of examples here that I wrote out, and we can go through a few of them together. And I'll tell you a little bit about what I noticed on one of your homework assignments that you all had last week. So when you're writing the formulas for ionic compounds, you always want to start with the charge on the ions. And looking at a periodic table, hopefully you have your agenda handy, because the periodic table in your agenda is super, super helpful. So if you don't have it, pause the video, dig out your agenda, and then start the video over again. And if you don't have your agenda at home, then look up a periodic table on the internet, or maybe you've got one in your notebook left over from one of our other classes. But if you're looking at the charges on aluminum, aluminum is group 13, I think, or group 3A. But the charge on aluminum is a plus 3, or 3 plus. And the charge on bromide is Br with a negative 1. So remember, for the crossing over method, you want to take just the numbers, not the sign. So I'm going to take just the 3 and the 1, and the 3 is going to become the subscript on the Br, and the 1 is going to become the subscript on the aluminum. So your final formula would just be AlBr3. So that's a binary kind. How do you know it's binary? Because that second element ends in "ide." If the second element ends in 8 or "ite," then that's a polyatomic or a ternary compound. But the process still works the same. Look up your charge on your cation. So in this case, it's magnesium. Magnesium is a alkaline earth metal, so it's in group 2 or group 2A. So it's a plus 2 charge. And then carbonate, remember, that's a polyatomic, and it is CO3 with a negative 2 charge. So if you have equal and opposite charges, if you do the crossing over or the crisscross method, then you would have to make sure that you reduce your subscripts. But if you can save yourself a step, just remember equal and opposite charges are going to cancel out as they are. So your final formula would just be MgCO3. Ammonium, remember, is the only positive polyatomic ion. So NH4 plus 1. Oxide, remember that's oxygen. How do we know? Because it ends in "ide." It's O with a -2 charge. So in this situation, when I have to move the 2 over and across to become my subscript on the ammonium, because ammonium is a polyatomic, I have to put ammonium in parentheses. So in this situation, NH4 will go in parentheses. The 2 will go next to it. And then I'm going to write my symbol for oxide. And remember, as I move my charge over and across, I don't have to write the 1. Well, I noticed looking at your homework assignments the other day that there were some problems that contained hydroxide. And hydroxide, even though it is just OH with a -1 charge, it is still a polyatomic. And you have to treat it like a polyatomic, even though there's not a subscript already there. So calcium is a +2 charge. So I bet you can think where I'm going with this. When you move the 2 over and across, because hydroxide is a polyatomic, you have to put hydroxide in parentheses. So your final formula would be CaOH in parentheses with a 2 there. And I noticed in the homework that there were several hydroxide problems that when you moved the subscript over, you guys didn't put the parentheses around it. So make sure that you take care of that. Go back and look at it. I think I still have the homework assignment, but I'll hand it out to you tomorrow right before the test. But anytime that you have a polyatomic ion and you need to move a subscript over, you have to put that polyatomic in parentheses. And then the last one, lithium dichromate. Dichromate's one of the polyatomics. It ends in 8. It's a not so common one. We haven't used it very often. So lithium is a +1 charge. How do we know that? Because lithium's in the first column on the periodic table, and all of those first column elements form a +1 charge. And then dichromate, yes, it starts with a prefix, but that is the name for that polyatomic. Remember, it is Cr2O7 with a -2 charge. So once again, move your charge over and across. So the lithium is going to have a 2 subscript. And then dichromate would then be Cr2O7. And since there's a 1 there, if the 1 moves across and down, I don't have to put it in parentheses, and I don't have to write the understood 1. So that's, once again, just a real quick tutorial on how to do the crossing over method or the crisscross method for writing the formulas for ionic compounds. I'll do the transition metals as a group separately, going both through how to write the names and how to write the formulas, so stay tuned.